Next, come for the types of digital image classification. So, digital image classifications are of different types. But very conventionally, it is said that the image classifications are of two types, like supervised and unsupervised. But these are not so very much accurate and logical. So, on the basis of the process and approaches, fundamentally, the digital classification is of two types, like hard and the soft. The hard classification is per pixel system and the soft classification is a spectral decomposition method. So hard classification is per pixel system where each and every pixel within an image has been studied. But in the soft classification system where the spectral values are decomposed to get the fractional coverage of the elements within a pixel. So that is very important. And under the hard classification system, we can include supervised, unsupervised, support vector machines, etc. And under the soft classification system, we can include the linear spectral mixing method or model, fuzzy logic, and spectral angle mapper, etc. So these are the two fundamental classification systems, and by mixing of both of them, or from the combination of these two classification approaches, we can get the hybrid classification system, which is very modern, and it is basically solved using the machine learning processes. So now let's come for the supervised classification system, which is very conventional and very general. Supervised classification system is such a hard classification scheme where user supervision is very needed and prior knowledge about the spectral characteristics of the features is very important. And in this technique, analysts select a small area to collect the signatures on the basis of the prior knowledge as training site on the image, and which in turn represents desired land cover category as a theme. So here, using the training site, we can collect the signatures about the features as a spectral class, and from this spectral class we can identify the feature class and which can be represented as a theme, and all this process is done using some kind of prior knowledge about the spectral characteristics, or using the rules of the pattern recognition. So here is the basic technique of the supervised classification system. And here the classes are clustered, or the class clustering using supervised classification is done using some distance measuring algorithms, where the unknown pixels or candidate pixels or unclassified pixels are measured with respect to the known pixels or classified pixels in regard to the spectral distance. So here what we have done in this case, the spectral distance between two pixels or between pixels are measured basically, and there are numbers of algorithms to classify the pixels in some classes, like the minimum distance to mean, maximum likelihood, and parallelepiped. So the minimum distance to mean classification algorithm, which is very common and very simple classifier. So I want to say you something, that the classification algorithms are basically classifier, because using these kind of algorithms we can group the pixels in some classes. So these are called the classifier. So this minimum distance to mean, or MXL means maximum likelihood, or parallelepiped, these are the classifiers. So minimum distance to mean is the most simple parametric algorithm, where a candidate pixel can be grouped to any cluster on the basis of the minimum distance to the mean of the clusters. Where there is minimum distance, the pixel will be grouped to that cluster. Like that, in this kind of demonstration here, this 1, 2, 3, these three are the candidate pixels. These are unclassified basically, and these are the clustered. So the question is now, in which class these candidate pixels will be grouped? So here, from these candidate pixels, mean distance have been calculated from the mean centers of each cluster, and these mean centers are called as the mean vector, and in which case we can see the smallest distance or the shortest distance, the candidate pixel will be grouped to that group. Means if for class, if for this pixel 1 the minimum distance is seen for this class of crop, this is the crop class of crop, so this pixel number 1 will be grouped to that class of crop. So here is the basic philosophy of this kind of the minimum distance to mean classifier algorithm. So next one is the maximum likelihood. It is very complex but very useful. This is also a parametric classifier algorithm. In this case, a candidate pixel can be grouped to any cluster with respect to the maximum probability in regard to some selected parameters. So what are those parameters? Here, the most important parameter is the statistical nature of the pixels. Like here, the parameter is mainly the concept of normal distribution. In this case, this has been considered that the radiometric value or DN value in each class fit a normal distribution, and on the basis of the probability density of that statistical nature of the signatures, a class can be determined. Means here a normal distribution has been calculated as a parameter, and then the candidate pixel statistical nature has been compared with the class statistics, and where there is a probability density is so high, the pixel will be grouped to that class. So in this diagram, it can be said that these are the clustered, and if a pixel like X has been studied to be grouped to any one of these clustered, then on the basis of the Gaussian distribution or the normal distribution of these two classes, firstly we have to calculate the significance level of these candidate pixels. Like here for this group A, suppose it is the class A and it is the class B. For class A, the confidence, the significance level is so high for this X like candidate pixel, but in this case of class, in this case of this class, the significance level is so low. That's why this X pixel should be classified to this group. So it is the actual thing about the maximum likelihood algorithm. Now come for the parallelopiped. So what is this? Parallelopiped is a non-parametric classification algorithm, and it is very much useful for the single class classification. Suppose if you want to classify the forest only from a satellite image, then you should use this parallelopiped algorithm. In this case, a class range is used, like maximum, minimum, mean, plus minus, different SD, etc. And for each category of training set, to group the pixels in a class, we have to read this kind of the range of this data set. That means here on the basis of the class pixels, we should calculate the maximum to minimum range, or we should define the mean plus minus SD, like mean plus minus 1 SD, mean plus minus 2 SD, etc, etc. And then the candidate pixels will be compared to that classes, and where the candidate pixel value is seen within that selected range, um,